Hi students, we are going to start problems from gravitation today. The first one, two spheres of masses 10 kg and 16 kg are 4 meter apart. Calculate the force of attraction between them. So we know the expression to find out the gravitational force of attraction between two bodies. Here the first body having a mass m1 which is equal to 10 kg, and the second body has a mass m2 which is equal to 16 kg. So m2 is equal to 16 kg, m1 is equal to 10 kg. Now the expression is the formula g m1 m2 by r square. What is the distance of separation here? This is 4 meter. So now let's substitute this value. 6.66 into 10 power minus 11, capital G value is given here. Product of the masses 10 kg into 16 kg by the distance between these two is 4. This is in meters, so directly you can write 16. So this 16 and 16 get cancelled. This will become 6.66 into 10 power minus 10. As it is, force unit is Newton. So this is a very simple problem. A body weighs 63 newtons on the surface of earth. On the surface of earth, weight of the body is 63 newtons. What is the gravitational force? That is nothing but weight only on it at a height equal to the half of the radius of earth. The radius of earth is r. Half of the height of the radius of earth is r by 2. What is the weight W2 here? We know that weight of the body is given by mg. Now you can write the weight on the surface of earth, this is equal to mg. This is given by 63 newtons. But m into, what is g on the surface of earth? This is capital G capital M by r square, which is equal to 63 newtons. This is equation 1. This is W on the earth. Now if it rises to a height here somewhere, then what is the weight of that body? Weight at a height is given by mgh. This is ge. So this is m is constant. What is g at a height? So this is given by gm by, from center to this point, this is r plus h. This is r plus h whole square. But what is h here? H is half of the radius of earth. So I can write this as m into gm by, this is r plus r by 2 whole square. So this is m into capital Gm by, this is 2r plus r, 3r by 2 whole square. So 3r by 2 whole square. This is m into capital Gm by 9r square by 4. 9r square by 4. So this is the value here. Now here what is the common? This 4 by 9 if you take common, the remaining terms are capital G capital M small m by r square. You can see this one, capital G capital M small m by r square is 63. So this will be 4 by 9 times of 63, 9 1s, so 9 7s. So this will become 28 newtons. That means at this point the gravitational force or the weight of the body will become 28 newtons. The earth mass is 80 times that of the moon, and their radii are 6,400 kilometers and 1,600 kilometers. What is the value of small g on moon if small g on earth is 9.8? We know the relation between small g and capital G and mass and this radii. So this is given by small g is equal to capital M by r square. Now on the surface of earth, if you take the mass of earth and radius of earth, this is given as 9.8 meter per second square. What is the small g on the surface of moon, they are asking. So small g on the surface of earth is given by capital G mass of earth by radius of earth whole square. So this is equation 1. Small g on moon is given by capital G capital M moon by radius of moon whole square. This is equation 2. Now by dividing 1 and 2, so dividing 1 with 2, we are going to get g on the surface of earth is 9.8. G on the moon, we are finding g on the surface of moon, which is given by g mass of earth by radius of earth whole square into radius of moon whole square by g into mass of moon. Capital G get cancelled. Now this will become 9.8 by g on moon is given by, what is mass of earth? 80 times that of the moon. So I am taking this as 80 m by radius of earth is 6400. I am not going to convert into meters. Why? Because even the radius of moon is also given in kilometers. So here also I am writing this 1600 whole square by mass of moon is m. So let the mass of moon is m and let the mass of earth will become 80 m. Here we have right. Let the mass of moon be m, then mass of earth will be 80 times of this one. So you can cancel this and this. This will be 9. G moon is given by, here this is 80. You can cancel this 0 and 0, 16 ones and 16 fours. 4 fours are 16. So this is by 16. 16 ones and 16 fives. So what is a small g on the moon? Small g on the moon is given by 9.8 by 5. 5 ones are 5, 48. 5 nines 45, 36. So the answer is 1.96 meter per second square. Calculate the value of escape velocity for a particle of a gas 1000 kilometers above the surface of earth. So first let me take the earth. So first option, on the earth, 1000 kilometers above surface of earth. So h is equal to 1000 kilometers. So what is escape velocity? The escape velocity is given by root over 2gm by r plus h. So now first let me take on the surface of earth, above the surface of earth actually here. So first one, above earth, this is given by root over 2. What is g? Here the data is given, mass of earth is this much, radius of earth is this much, and capital G value is this much. So this is 6.67 into 10 power minus 11. Mass of earth is 5.98 into 10 power 24 by radius of earth is 6.37 into 10 power 6 meters plus height above surface of earth is 1000 kilometers. So this is 10 power 6 meters. 1000 kilometers can be written as 10 power 6 meters. So what is the escape velocity at that height? This is given by 2 into 6.67 into 5.98 by, if you take 10 power 6 common here, 10 power 6, 6.37 plus 1, 7.37, and this is powers are 10 power 24 minus 11, 10 power 13. So the escape velocity above the surface of earth is given by 2 into 6.67 into 5.98 is given by 79.77 into 10 power 13 by 7.37 into 10 power 6. So this is divided by 7.37, which is given by 10.82 into, when it goes up 10 power 13 minus 6, 10 power 7 under root. So this escape velocity is given by root over 10.82. So this is 3.289 in, but this is 10 power 7. So what I am going to write? I am going to write this as root over 100.82 into 10 power 6. Root 100.82 under root will be 10.04 into 10 power 3 meter per second, or 10.04 kilometer per second. This is the escape velocity at a height of 1000 kilometers above the surface of Earth. One part of this problem is 1000 kilometers above the moon. So now let me erase this one. Let me keep it as a 2 above moon. This is let me take it as V moon. 2gm, where m is mass of the moon. Now the mass of the moon in this problem is given as the mass of the moon 7.349 into 10 power 22 by radius of the moon 1.73 10 power 6. So this is 1.738 10 power 6 into plus 1000 pounds above this one. So by substituting all these values by simplification, you will get this value as so this will be 2 into 6.67 into 7.349 into 10 power 11 by 10 power 6 common. This is 2.738. So this can be written as 2 into, so this is 1.89 into 10 power 3 meter per second. Similarly, you can use the data given for sun, and you please solve this problem by using this same formula. Find out the escape velocity 1000 kilometers above the earth surface. Assuming the earth to be a sphere of uniform density, so this is our earth of uniform density. How much would a body weigh halfway down the center of the earth if it weighs 250 on the surface? So on the surface of earth it was 250 newtons. Halfway down, this is the radius r. So this distance is depth is equal to r by 2. What is the weight here? The weight of the body is given by mg on earth, on the surface of earth. This is m into g on surface. Now, if you take this point, then weight at depth, at some depth is given by m into g at some depth. Now, if you divide these two, this is equation 1, this is equation 2, 1 by 2 gives the weight on the surface of earth was, it is given as 250. This is weight at some depth, which is given by mg on the surface of earth by mg on the at a depth. Get cancelled. So now by cross multiplication, weight at a depth is given by 250 into g depth by g surface. 250 into 1 minus r get cancelled, this 1 by 2. So half into 250, this will be 125 newtons. Next one, calculate the orbital velocity of a body near to the surface of the earth. So this is our earth, radius r, mass m. So there is a body which is very close to the surface of earth. What is the orbital velocity? This is given by root over gm by r only. Here in general in PUC they will give g value, m value, r value. So we have to substitute because all are known values now. 6.67 into 10 power minus 11. Mass of earth 6 into 10 power 24 by radius of earth 6400 kilometers. So by substituting all these values here, by calculating this value, we are going to get 6.67 into 6, which is 40.02 by, this is 6.4 10 power 6, so 6.4 into 10 power 6, this is 10 power 13. So 40.02 divided by 6.4, which is given by 6.25 into 10 power, when 6 goes up, this will become 7 under root 2, or 62.5 into 10 power 6 under root 2. So what is this 62.5 under root 2? This is 7.9 into 10 power 3 meter per second, or 7.9 kilometer per second. 80 kg on the surface of earth. How much will he weight on the surface of the Mars? given that the mass of the earth is 8 times that of the Mars and radius is twice that of Mars. Remember, this is 80 kg, actually this is not weight, but it is given as weight, so we take it as 80 newtons only on the surface of the earth. How much he will weight on the surface of Mars? We know that weight of the person mg, which is equal to m into g, is equal to capital G m by r square. Now here we are comparing earth with Mars. So this is earth, this is Mars. Here given that mass of the earth is 8 times that of the Mars, so if mass of the Mars is m, mass of earth will be 8m, and radius twice that of the Mars. Radius of the Mars is r, this will become twice the radius. Now I am going to do this problem. Weight is equal to capital G capital M small m by r square multiplication. Now weight on the earth by weight on the Mars is given by capital G mass of earth, mass of this person by r square of radius of earth whole square by radius of Mars whole square by capital G mass of Mars into m. This get cancelled. So what is the weight of the person on the earth? 80 by weight on the Mars is given by mass of earth is 8m, radius is 2r whole square, this is r square by this mass of Mars is m. You can cancel the m and m, this r and r get cancelled, this will become 8 by 2 square is 4 ones 2. So weight of the person on the Mars is given by 40 newtons. As it is given in kg, you take it as 40 kg. Eighth problem. A body rises to a height 500 kilometers. What is acceleration of gravity at this point? If a body rises to a height of 500 kilometers, what is small g? Small g is given by capital G capital M by r plus h whole square. So this is 6.67 into 10 power minus 11. Earth mass 6 into 10 power 24 by radius 6.4 into 10 power 6 plus height 500 kilometers. So 500 10 power 3 or 0.5 into 10 power 6 whole square. So this will become 6.67 into 6 into 10 power 13 by, this is 6.4 plus 0.5. So this is 6.9 into 10 power 6 whole square. So by using this one, 6.67 into 6 will be 40.02 by 6.9 into 6.9 will be 47.61. This is 10 power 13, this is a 10 power 12. So this can be written as 40.02 by 47.61 into, this is 10. Now 400.2 divided by 47.61 is equal to 8.45 meter per second. A body is raised to a height 500 kilometers. With what velocity should this body be projected? In a direction perpendicular to the line joining the center of the earth and the body, so that it describes a circle about the earth. So this is our earth. A body is raised to a height of 500 kilometers. So this is the position of the body. With what velocity should the body be projected in direction perpendicular to the line joining the center of earth and the body? If we join these two, perpendicular to this one, what should be the velocity such that it moves in a circular path? That is nothing but the orbital velocity of this body around earth. So the orbital velocity is given by root over gm by r plus h. So this is given by 6.67 into 10 power minus 11, and the mass of earth 6 into 10 power 24 by r is 6400 kilometers plus 500 kilometers. Now the velocity that should be given, which is also known as orbital velocity, which is given by root over 6.67 into 6 into 10 power 13 by 6400 plus 500, 6900 into 10 power 3. So this can also be written as root over 6.67 into 6 into 10 power 13 by, this is 6.9 into, this will become 10 power 6. So this will be 6.67 into 6 by 6.9 into, when it goes to 10 power minus 6, so this will become 10 power 7 under root. Now this value is 6.67 into 6 is 40.02. So this is 40.02 into 10 power 7 by 6.9, which can also be written as 400.2 into 10 power 6 by 6.9 under root. So this value 400.2 divided by 6.9 is equal to, this is exactly 58. So root over 58 into 10 power 6. So what is root 58? The root 58 value is 7.6. So this is 7.6 into, this is under root. So 10 power root is 10 power 3 meter per second. So the velocity that should be provided for this one is 7.6 kilometer per second. 7.61, this is 7.61 kilometer per second. A body is raised to a height of 500 kilometers above the surface of earth. What will be the period of revolution of the body about the earth? Given that radius of the earth is 6500 kilometers and small g is equal to 9.8. So this is our earth. Radius r is given and at a height h 500 kilometers a body is revolving around the earth. So what is the time period formula? Time period is equal to 2 pi r by that velocity in that orbit, which you call it as orbital velocity. So t is equal to 2 pi, this r is from here to here r and this is h. Total r will be r plus h by root over gm by r plus h. So time period is 2 pi r plus h root over r plus h by gm. So now if you substitute this value, 2 into, this is 22 by 7, radius of earth is 6500, height above the surface of earth is 500, these two are in kilometers into root over r plus h by gm. So this is r plus h into r plus h whole power 1 by 2. So 2 pi r plus h whole power 3 by 2 by root gm. So this I am going to write this as 3 by 2 by root over g is equal to 6.67 into 10 power minus 11 and mass of earth 6 into 10 power 24 kg. But in this problem, instead of capital G, capital M, they have given small g. We know small g is equal to capital Gm by r square at a height here, small g. So now in place of Gm you can write small g into r square also. So in place of that, if I write small g into r square, this will become root gm can be written as a small g into r square. So this is small g into r square. Here r is equal to not capital R, this is r plus h whole square. So this will become root g into root r plus h whole square means r plus h only. So this is 22, so this will become 44 by 7. This is 6500 plus 500, 7000 into 10 power 3 whole power 3 by 2 by root over 9.8. R plus h is this value only, that is 7 into 10 power 6. Now this will become 44 by 7 is 6.28. This is 7 into 10 power 6, 7 into 10 power 6 whole power 3 by 2 by root 9.8 is 3.13 into 7 into 10 power 6. You can see these two values are same. This is power 1, this is power 1 by 2. So 6.28 by 3.14. 6.28 divided by 3.13 is 2.006. So let me take it as nearly 2. So this 2 into this 1 when goes up they become 1 by 2, that is root over 7 into 10 power 6. So this is 2 into root 7, 2.645, 645 into 10 power 3 seconds. This is the time period of that body around the earth. But I need this in seconds only, so I got it in seconds. But sometimes it is better to convert this into hours or minutes. So first let me convert this into this one. This is 2.6 into 2. This is 5.29. 5.29 1 into 10 power 3 seconds or 5291 seconds. So this is the time period of this one, that is 5291. But we know that 1 hour is equal to 3600 seconds. So what is this 5291? So T can also be written as 5291 seconds, or this is 3600 seconds plus then 3600 seconds plus 5291 seconds can be written as this plus some other value. So what is this 5291 minus 3600? This will be 1691. So extra seconds are 1691 seconds. This is 3600 exactly equal to 1 hour. So the time period of this one is 1 hour 1691 seconds. So divided with 60 you will get in minutes. So this is 28. So 1 hour 28 minutes. Remember students, in general you can leave this answer somewhere here itself. If you write the time period in seconds, that will be the final answer. But especially in competitive exams, instead of seconds, sometimes in options they may give this in hours as well as in minutes. So like this, 1 hour 28 minutes, 1 hour 42 minutes, 2 hours 48 minutes, or 3 hours 19 seconds, or like that. So we have to better to convert this into minutes and then in seconds. So this will be the answer for this one. A rocket is fired from the earth towards the sun. So this is our earth and this is the sun here. So one rocket is fired from the earth towards the sun in this direction. So this is the rocket. Now from the earth center, is the gravitational force on the rocket is 0. At what distance from the earth center? So this is the center of our earth. This is the line joining the sun and this earth. At what point the gravitational force is 0? So this is the point, let us say, where the gravitational force is 0. When the gravitational force on rocket is 0 means, so this will not be attracted by sun or earth. So it will be in equilibrium at this point. So we want to find out that one. So I need this distance of point free from the center of earth. Now what is the other that it is given here? Mass of sun is given as ms. This is 2 into 10 power 30 kg. Similarly, mass of earth is me, 6 into 10 power 24 kg. Neglect the effect of other planets, etc. Orbital radius is 1.5 10 power 11 because earth revolves around the sun. So what is the distance between center of earth to the center of sun? This is equal to 1.5 into 10 power 11 meters. So this is the given problem. So based on this one, at point P there is no gravitational force on the rocket. So at P the net force on the rocket is equal to 0. Why the net force is 0? If the rocket reaches this point, sun attracts with some force and earth also attracts with this equal force, but these two forces are equal and opposite. So this will be attracted in this direction. So this is the force of attraction by sun. This is the force of attraction by earth on the rocket. So as net force is 0, these two forces are equal and opposite. So force experienced by the sun, rocket due to sun is equal to force experienced by rocket due to earth. So what is this formula? This is nothing but a gravitational force only. So capital G, mass of sun, mass of rocket by what is the distance between this point and the center of sun. So if it is 1.5 10 to the power 11, if it is r, and this would be 1.5 into 10 to the power 11 minus r whole square. This is the capital G small m1 m2 by r square. This must be equal to capital G mass of earth, mass of rocket by what is the distance between earth and rocket. This is exactly r square that we are finding. You can cancel this capital G capital M, and it does not depend upon the mass of the rocket. Now what is the mass of the sun? Given as 2 in 10 power 30. This is 2 into 10 power 30 by 1.5 into 10 power 11 minus r whole square is equal. Mass of earth is 6 into 10 power 24 by r square. So once again you can cancel this 2 1s and 2 3s, and this is 10 power 30 when it comes to 10 power minus 24. So this is 10 power 6. So 10 power 6, this 3 will come down. 3 into 1.5 into 10 power 11 minus r whole square is equal 1 by r square. So this is the expression. Now you bring this one this side. You can write 10 power 6 by 3. When it goes that side, this will become 1.5 into 10 power 11 minus r by r whole square. So this you can write 1.5 by r. This is 1.5 into 10 power 11 by r minus 1 into whole square. So I need this r value. Now I got this one. So this is a square. When it comes this side, this will become 10 power 6 by 3 whole power 1 by 2 is equal 1.5 into 10 power 11 by r minus 1. When this minus 1 also comes this side, this will become 1 plus. So I can erase this one. So this is the expression. So from this, what is this 1 value plus 10 power 6 whole power 1 by 2 means 10 power 3 only. So here I am writing 1 plus 10 power 3 by root 3. 1 plus 10 power 3 by root 3 is equal. On right side we have 1.5 10 power 11 by r. 1.5 into 10 power 11 by r. I need r value. So first let me find out this. 1 plus 10 power 3 means 1000. 1000 by root 3. 1000 by root 3 means 1.732 divided by 1.732, which gives 577. 577.36 is equal 1.5 into 10 power 11 by r. I need r value. This is 577.36 plus 1, 587.36. So r is equal, let just replace these two, interchange these two values. This is 587.3. So 1.5 into 10 power 11 by 587.36. So this can also be as it is 10 power 11. So this r value will be 1500 into 10 power 8 by 587.36. Now you can write this as 1500 divided by 587.36, which is equal to 2.55. So r should be 2.55 into 10 power 8 meters from the surface of earth. So what is this r value? The r value in this case is given by, this will be 502.55 into, this will be 2.55 into 10 power 8 meters, or as this distance is given in kilometers, as it is in meters, you can leave it in meters, but this can also be mentioned as, this is the final expression, or this can also be written as 2.55 into 10 power 5 kilometers. Io, one of the satellites of Jupiter, has an orbital period of 1.769 days, and the radius of the earth is radius of the orbit is 4.2 10 to the power 8 meters. So that the mass of the Jupiter is about 1,000th of the sun. So first let me take Jupiter here. So this is the Jupiter. So I am keeping it as J, and it has a satellite, and the name of the satellite is I0. So what is the time taken by I0 to revolve around this Jupiter? So the time period of this I naught is given by 1.769 days. Remember, the natural satellite of our Earth is Moon. It is taking exactly 1 day, but here it is taking 1.769 days. So now I need to compare the mass of this Jupiter with the mass of the Sun. So first let me use this one. Orbital speed is given by root over g mass of Jupiter by radius of this one. What is the radius of this orbit? This is given as 4.22 × 10⁸. So here as the time period is given, we can write time period is equal to 2 pi r by v naught. This is 2 pi r by root over gm by root r. So time period is 2 pi r power 1, r power 1 by 2 will become r power 3 by 2 by gm whole power half, where m is the mass of the Jupiter here. So now let me substitute these values. Time period for I naught is given by 2 pi is 22 by 7. Radius of this orbit is 4.22 into 10⁸ meters whole power 3 by 2 by g is equal to 6.67 into 10⁻⁻11, and the mass of Jupiter we don't know. These multiplication of these two whole power 1 by 2. Let me take it as equation 1. But I know the time period of I naught, which is given as 1.769 days. So in place of this t I naught, what I am going to write? This is 1.769 days. So this is part 1 of this problem. In part 2, what I am going to write? I am going to take the Earth as our this one. So if I take the Sun here, this is the Sun, and from here our Earth is rotating in a circular orbit. The astronomical unit is the distance between Earth and the Sun, which is given as 1.5 into 10⁻11 meters. This we have to remember, already you studied this value in lower classes. Now, what is the time period of our Earth? Once again, the expression is 2 pi r power 3 by 2 by g mass of Sun whole power 1 by 2. Remember, if Earth is revolving around the Sun, then we have to consider this mass of the Sun. If I naught is revolving around the Jupiter, we need to take mass of Jupiter. So here what I am going to write, the time period of our Earth, this is 1.769 days, but Earth is 365 days is equal. This is also in days and this is also in days. So I am not converting this into seconds here. This will be 2 into 22 by 7 into the astronomical unit is 1.5 into 10⁻11 meters whole power 3 by 2 by g is equal to 6.67 into 10⁻11, and the mass of Sun is unknown here. So whole power 1 by 2, equation 2. So I got the two equations. So by comparing these two equations, the only unknown quantity in these two is mass of Sun and mass of Jupiter. So now I am going to compare the masses of Sun as well as mass of Jupiter, and I have to show that these two are equal to 1 by 100 times of the other one. That is, mass of Jupiter is 1 by 100th mass of the Sun. 2 with 1. So equation 2 by equation 1. What is equation 2? That is 365 days. So left side I am going to write 365 days is equal this value 2 into 22 by 7 into this value 1.5 into 10⁻11 whole power 3 by 2 by denominator is 6.67 into 10⁻11 into this is ms. This is mass of Sun whole power 1 by 2 by this is the second equation. So what is the first equation? This is 1.769 is equal 2 into 22 by 7 into this distance is 4.22 into 10⁸ whole power 3 by 2 by denominator is 6.67 into 10⁻11 into mass of Jupiter whole power 1 by 2. Now what are the quantities that can be cancelled here? You can see this 222 by 7, 222 by 7 can be cancelled. Similarly, this capital G can be cancelled here. So this is in days, this is also in days. Even if you convert this days into seconds, here you can cancel these seconds also, but here not required. Now the remaining steps are from this what I am going to write. Now I am going to write this as 365 by 1.769 is equal. In numerator, this is 1.5 into 10 power 11 whole power 3 by 2 by mass of sun under root. This is 1 by 2 means under root. When it goes up, this will become mass of Jupiter by, this will be 4.22 into 10 power 8 whole power 3 by 2. So what is this 3 by 2? 3 by 2 can also be written as 1 plus 1 by 2. So now I am going to use the calculator here. Squaring on both sides. First of all, this whole square, 365 divided by 1.769, which is given by 206.33. So this is a 206.33 whole square left side. Right side, squaring, you will get mj by ms. So you will get mj by ms. This is mass of Jupiter by mass of sun. And when you are squaring this one, this will become this cube by this cube. That is 1.5 into 10 power 11 by 4.22 into 10 power 8 whole cube only. Now 206.33 into 206.33 will be 42572.3. This is 42572.32. This is the left side value, and right side we have mass of Jupiter by mass of sun. You can see this 10 power 8, this cancel 10 power 3. So this is 1.5 into 10 power 3 by 4.22 whole cube. So now I am going to solve this problem here. So now I can write 42,572.32 can be written as mass of Jupiter by mass of sun into, this is 1.5 into 1000 means 1.5 means 1500, 1500 by denominator is 4.22 whole cube. So this is 1500 divided by 4.22, which is given by 357.14. So this is 357.14 whole cube. Now I need to compare the mass of Jupiter with the mass of sun. So now let me keep this mass of Jupiter by mass of sun here. You bring this one this side. This will become 42,572 by 357.14 whole cube. Now 357.14 into 357.14 into 357.14 is equal to 45552842. So this is 42572 by, this value is 4552842.7. So now you can see this one. If you divide these two, you will get the mass of Jupiter by mass of sun is, this value will be, so once again 42572 divided by 4552842. So this will be 0.000934, 0.000934. This is mass of Jupiter by mass of Sun. If you reverse this one, mass of Jupiter is equal 0.000934 mass of Sun. So mass of Jupiter is equal, if you compare this value, if you, this one 0.9 means, so this is a 10 power nearly 10 power minus 3 mass of this one. So mass of Jupiter is 1 by 1000 nearly, not exactly, mass of Sun. So this is how we can find, we can prove that mass of Jupiter is nearly 1 by 1000 times the mass of the Sun.